Alright, in this video we are looking at a difficult network diagram with lag. Completely unrealistic problem, but who knows, if you're taking this in school, your teacher might just be mean enough to give you something like this. So let's go and do the Gantt chart, and then after we'll make our PDM network diagram. So first up, let's set up our Gantt chart. So now our first activity in the project will be activity A because it has no predecessor. It has a duration of 3, so it will go from 0 to 1, 2, 3. There it goes till the end of day 3. Activity B depends on A. It's a finish to start relationship with a lag of 2. So that means we have to find the end of A, count 2 days for our lag, and then because it's a regular finish to start relationship, that means we can start at that point that's 2 days after, and then we'll go for 2 days because that's what its duration is. Alright, so activity C depends on A, and it's a start-start relationship, so that means activity C can start when A starts. There's no lag, so we will start right at this 0 again. And this one's also 2 days, so we will just go to that 2 there. Activity D. This guy depends on activity B. It's a start-start relationship with a lag of 1. So we find where B starts, come down to D, because we're looking at activity D now, and it's a lag of 1, so we'll go out 1. And this is 4 days long, so we'll go from 6 out to 10, right? 1, 2, 3, 4. All right, activity E. This guy depends on activity C, and it's a start to finish relationship of 3. All right, so the start to finish relationship is the weirdest one. First of all, let's figure out what the lag is. So it's a lag of 3. So we come out from the start of C, we go 1, 2, 3. And because it's a start to finish relationship, that means that E can finish 3 days after C starts. And it's a duration of 1, so we'll just count back 1 from there. And that's where we'll get activity E happening. It'll go for just this 1 day here. Alright, activity F. This is depends on C, and it's finish-finish relationship with a lag of 3. So let's find out where C finishes. Okay, it finishes on the 2 here. Finish relationship with a lag of 3, so that means that F can finish 3 days after C can finish. Okay, so we'll count 3 days out, 1, 2, 3. So that will be the finish point of F, but it has a duration of 2, so that means it would have to start on the 3 if it's going to finish here on the 5. Activity G. This depends on 2 things. It depends on D and E, and specifically for D, it's a start-start relationship of 1, or with a lag of 1. So first, let's see where that would be. So activity G, D starts up here on the 6. So if we were going to go by that, we would have a start with a lag of 1. So this would be its potential starting point. But we also have to consider that it can't start before E is over. Like E has to be done before G can start. So let's go find where E is. Okay, well E is finishing here on 3, and that's just a regular finish to start relationship. So that would be the other potential starting place. But we can't start here because it would violate the start with a lag of 1 coming off of D. So we have to satisfy both, so that will be this guy here. And so we'll go out 4 days for its duration. 1, 2, 3, 4, just like that. Okay, so now activity H. It also has to satisfy 2 things. It depends on F with a start to finish relationship of 2. So let's look at this guy. So where's F? F is here. Start to finish relationship of 2. So we find the start of F, that would be here, and then that means the finish of G could be 2 days after that. So that's where the finish would be, and it's 3 days long. So 1, 2, 3. Okay, so that right here is the potential, one of the potential start dates, and also we have it has to depend on G. So it's a regular finish to start relationship off of G. So the other potential start date is right there. Well, right away, if we started here, we would be violating the fact that activity H can't start until G is done, so this has to be the start date. So we'll start it here, and it's 3 days long, so go 1, 2, 3. Okay, so now let's draw the PDM network diagram. I fast forwarded it because it's a long, boring process that I don't want you to have to just sit through and watch me draw, but I encourage you to check for yourself to make sure this is all correct. Now, so we'll do our forward pass and then our backward pass, and then that should be enough to wrap up this video. So let's go ahead and we'll also compare it to our Gantt chart and make sure that everything matches up. Okay, so for activity A, starts at the beginning, so we have 0 plus 3, early finish is 3, and let's just fill out B. So we have a finish to start relationship with B with a lag of 2. So that means that activity B's earliest start is just 2 days after A's early finish. So 3 plus 2, we're going to get a 5 in there. 5 plus 2 is 7 for the early finish. For D, the start with a lag of 1 coming off of B. That means activity D can start 1 day after activity B. So it will start on 6, we'll have 6 plus 4, and it will end. Its earliest finish will be on 10. We can't fill this out yet because it has two competing values. So we'll come back down here. C is a start-start relationship coming off of A. So it can start when A starts. So we have this 0, then 0 plus 2. We get its earliest finish is 2. Start to finish relationship with a lag of 3. So E's finish will be 3 days after C's start. So we're going to have 0 plus 3, we'll add the lag, so we'll get the 3 in the early finish, and then to find the early start, we'll have to subtract the duration. So this guy would start on 2. Now for activity F, finish to finish relationship with a lag of 3, so that means F can finish 3 days after C finishes. So 2 plus 3 is 5 for the early finish, and then again we'll have to subtract the duration to figure out when that guy has to start, so it'll be 5 minus 2 will give us 3. So coming into the earliest start for G, we can either have a start plus 1. So coming off of D, the start plus 1, that would be 6 plus 1 is 7. So we can either have 7 to go in the early start, or we can have 3, right? Just a regular finish to start relationship. And we're going to have to pick the largest value, so we will take the 7. So we'll erase those guys and we'll add in the 7. That way it satisfies both requirements that D and E, the logic is satisfied. So 7 plus 4, that would give us the earliest finish of 11. And then looking here at activity H, its earliest start, according to F, well, that'd be start, finish, 2. So that means it could finish 2 days after F starts. So that would be 3. So its finish could be 5, and then subtracting the 3 here, its potential start based on the requirement for F would be the second day. According to G, it's a regular finish to start relationship, so we would just have to bring the 11 in. So we could also have 11. Well, 11 is the greater than 2, so 11 wins. We have to take the larger value in order to satisfy both of these predecessor relationships. So we will be putting in 11 as the early start of H, and then to add 3, we get 14 for our project duration. Now, at this point we can compare and see if we got the same values with our Gantt chart and then the early start, early finish of our PDM network diagram. So A goes from 0 to 3, A goes from 0 to 3. B goes from 5 to 7. On the Gantt chart it also goes from 5 to 7. Activity D goes from 6 till 10, so on the Gantt chart it also goes from 6 till 10. Activity C goes from 0 to 2, 0 to 2, that looks okay. Activity E goes from 2 to 3, that checks out. Activity F goes from 3 to 5. Where's activity F? 3 to 5. Same thing. Did we already do G? No, not yet. So G goes from 7 till 11. Same on the PDM network diagram. And H goes from 11 to 14. It looks good. So that's just highlighting the fact that you can do this visually using a Gantt chart, or you can get the same results by doing your forward pass in your PDM network diagram. And it's a good way to cross-check between the two and make sure that you've done it correctly. Okay, so now let's do the backwards pass, and this will get a little crazy, but we'll work our way through it. So we'll bring down this 14 and subtract 3 to get 11. Now this is a regular finish to start relationship, so we can just bring that 11 right in just like that and subtract 4 and get 7. You know what, let's do as many as we can that seem easy. This is also a regular finish to start relationship, so we can bring the 7 right in here. 7 minus 1 will get a 6. Now looking up here at activity D, this is a start-start relationship with a lag of 1. So that means that G can start 1 day after D starts. That's regardless, that is for the early start or the late start. So in this case it's 7. This guy starts at 7 and it starts 1 day after D, so we'll just have to subtract 1 and put that 6 right in there. And then we'll be able to find the late finish by adding the duration, so we'll get 10. Okay, we can do the same thing here for activity B. It's another start-start relationship with a lag of 1. So again, take this start, subtract 1 from it, and put that number here. We get 5. 5 plus 2 is 7. Okay, we can't fill this out because there's competing values. Can't fill this out because there's competing values. So we got to figure out this guy. This is a start to finish relationship with a lag of 2. So that means activities H can finish 2 days after activity F starts. So what we do is we identify the finish of this, it's 14, and this guy can start 2 days before, so we would bring a 12 in here, right? 14 minus 2 for that lag, and then we just add this, and we're going to find out that this is our late finish of 14 because that's 12 plus 2. All right, now looking at competing values, going on the backward pass, we need to take the smallest value. So here it gets a little tricky. This is a start to finish relationship with a lag of 3 coming off of E. So E's late finish is 7, so we have to subtract 3 from that. That would give us 4. And so that would potentially give us a start date of 4 down here, which then we would have 4 plus 2, that would give us a potential late finish of 6. Then according to this finish-finish relationship with a lag of 3, we would have 14, so this guy could finish 3 days before that, so we would have 14 minus 3, so that could also be 11, and that would give us a minus 2 and a potential late start of 9. But on the backward pass, we have to pick the smallest value here, so it will in fact be the 6 for the late finish and not the 11, so we can go and erase those guys. And we'll get a 6 here, subtract the 2, and we will get a 4 for our late start, sorry. Now looking at this one, we have two options again. We can bring in start relationship, so according to this guy, we could potentially start on a 4 here, or also we have finish to start minus 2. So what we're saying here is that this guy can start 2 days after this one finishes, so we would take this 5 and we would subtract 2 from it. We would be able to bring in that 3. And if we had this 4 here, this would actually, if you add the 3, we would get a 7, 2 competing values for the late finish. But we have to take the smaller one on the backward pass, so the 3 will win here. So we'll get that 3 in there. 3 minus 3 is 0, and ending on 0, you know you've done it correctly. And again, just a reminder that this is an entirely unrealistic problem. I just put in basically the hardest problem I could think of right now, just to work through the forward and backward pass, but totally unrealistic in real life or anything like that. But who knows, you might have a really mean teacher that's going to throw something like this at you at a test.